we go, Algebra 2 students. This is another Regents review video. This is the Algebra 2 Common Core Regents for August 2017 administration of this exam. These are going to be the solutions to Part 1 questions 1 through 12 of this exam. And without further ado, let's talk about a few things before we begin here. As usual, this is Algebra 2. This is Big Boy and Girl League. Do not, under any circumstances, cheat off of this video. It is so not worth your time, effort, and energy to do that, because this is by far probably the hardest of the 3 mathematics sequences you'll ever take for the Regents exam. Geometry's tough. Algebra 2 is a little bit more challenging. So please don't cheat. Try the problems by yourself, and if you have trouble, then come back here. And that's all I have to say about cheating, because I just don't like it. Make sure to hit that subscribe button down below, consider becoming a patron on my Patreon page, and visit my website at www.nysmathreadersprep.com for more math content in Algebra 2 and all your future mathematical subjects. Both of those links can be found in the description below. And I use the TI Inspire CX calculator, quite the powerful tool. Best calculator, in my opinion, on the market. That link could also be found on my website. So lots of things on my website, including my Facts You Must Know codes for the Algebra 2 Regents, which will help you answer some of these questions. Without further ado, here we go. Number 1. The function f of x equals x minus 3 over x squared plus 2x minus 8 is undefined when x equals 1. Well, undefined means where is there a break or a discontinuity in this particular function. Now, I'm going to go do my calculator first just to show you a visual depiction of what it would look like, but I do not recommend finding your answer like this, because you should know how to do it. So, if I type this into my calculator, like so, we get this. So we see a bunch of breaks here. Now, you could somewhat eyeball and say, well, it looks like x equals, I don't know, 2, and maybe like negative 1, 2, 3, 4, maybe negative 5, negative 4, somewhere in that range. I just wouldn't do it like that. You are smart people. You know that a fraction is undefined when you take the denominator and set it equal to the number 0. When you take the denominator and set it equal to 0, those are the x values that it cannot be defined at. So all you do is you take the denominator, x squared plus 2x minus 8, and you just simply set it equal to 0 and solve for x. This is just a basic factoring question. What adds to positive 2 and multiplies to give you negative 8? That's just going to be x plus 4, x minus 2, because 4 times negative 2 is negative 8. 4 plus negative 2 is positive 2. Set that equal to 0. Do your t-bar and solve. So you get x plus 4 equals 0. Subtract the 4 on both sides, and you get x is equal to negative 4. Over on this side, you get x minus 2 equals 0. You add that 2 on both sides, and we get x is equal to the number 2. So your answer is actually choice 1, 2 or negative 4. Those are the values. When you input those two values into f of x, that's where the denominator is 0. Undefined in this context means when is the denominator 0, okay? And we know that the denominator can never be 0 because that's where it's undefined, and that's exactly what the question is asking you to do. So your answer is choice 1. Moving on to question number 2. Which expression is equivalent to 3k minus 2i squared, where I is the imaginary unit? So whenever you see a squared, and you see a binomial or trinomial, whatever it is, you just write it twice, and you solve. So this is really saying, solve for 3k minus 2i, 3k minus 2i. Oops, that's not a good I. 2i. Now, from here, you just simply distribute. So we do the first, the outer, the inner, and the last. If you like FOIL, I just say distribute. So 3k times 3k is 9k squared. Okay. 3k times negative 2i, that's going to be negative 6ki. Do the same thing in the middle. So negative 2i times 3k is negative 6ki. Now this is where it gets tricky. Negative 2i times a negative 2i is a positive 4i squared. Okay. So now let's further simplify the problem. We can combine like terms in the middle. Those are like terms. We know that for sure. The I squared over here, by the way, is actually equivalent to the number negative 1. If you just verify that on your calculator, you can, if you forget your powers of I. Go to your calculator page. In the pi button, there's a little I symbol. I squared is equal to negative 1. So from here, we just rewrite this as 9k squared minus 12ki minus 4, because this is really now saying 4 times negative 1, which is negative 4. So your answer for this question, if you just match it up, is going to be choice 3 for that question. All right, moving on to question number 3. 3 says the roots of the equation x squared plus 2x plus 5 equals 0 are what? So the first thing that we want to do is we want to think of the order of factoring. We know that it's GCF followed by dots followed by the trinomial method. Then if it doesn't work, then apply some other things. So is there a greatest common factor here? No, I don't see one. Is it the difference of two perfect squares? No, that's not it either. Well, this is clearly a trinomial. Well, let's try the AM method of factoring. Okay, what adds to positive 2 multiplies to give you 5? I can't think of any two numbers that add to give you 2 and multiply to give you 5. So, you have two options. Since this is not factorable by anything that we could apply, we could either use the quadratic formula or completing the square. Now, honestly, I would do completing the square. It's just a little bit quicker and possibly easier. If you like the quadratic formula, then go for it. But what I'm going to do is I'm just going to say, okay, x squared plus 2x is equal to negative 5. You keep the letters on one side of the equation, numbers on the other side of the equation. So from here, I'm going to insert my blank spaces. X squared plus 2x plus something is equal to negative 5 plus something. Okay, well, what goes in that box or that blank space? Well, you remember the formula, b divided by 2 squared. And that's exactly what we're going to do. We take this, we apply the formula b divided by 2 squared, and we solve. Well, b is the middle term, or the middle coefficient. So the middle coefficient is 2. So that's just going to be 2 divided by 2 squared. 2 divided by 2 is 1. 1 squared is just 1. So plug in the 1. Now this is important. Now it's factorable. This is all factorable here. Now we could say, okay, what adds to 2 and multiplies to give you 1? Well, in completing the square, it has to be the same two factors. It's x plus 1, x plus 1. Because 1 times 1 is 1, 1 plus 1 is 2. That's good so far. That equals negative 4, okay? X plus 1 can be rewritten as x plus 1 quantity squared equals negative 4. Now, to solve for x, we take the square root of both sides. Now, immediately you should see some sort of a problem. We could take the square root of this. That's just x plus 1. You see a problem over here. What's the square root of negative 4? Well, the square root of negative 4 is going to give you an imaginary number. So if we break down the square root of negative 4, we know that it breaks it down into two separate radicals. One of them being the square root of 4, and the other one being the square root of 1, which is the imaginary unit. The square root of negative 1 is your power of I. And the square root of 4 is just 2. So it's 2i. But don't forget about that plus minus. So the square root of negative 4 is plus or minus 2i. Continue to solve for x. Subtract the 1 on both sides, and we get x is equal to negative 1 plus or minus 2i. When you rewrite that, make sure it's an a plus bi form. That's probably the best way. But when you just break it down, this is negative 1 plus 2i and negative 1 minus 2i. And these, ladies and gentlemen, are your answers. We're looking for those roots of the equation. Your answer is choice 3 for that question. All right, just a nice imaginary unit question. Not too bad of a question. But then we get a little bit worse. So number 4, in my opinion, was the hardest question on the exam. Of course, it's doable. They just decided to throw 2 radicals on there. I never seen it before, but that's okay. This is the first time that they're testing this. Let's go ahead and give it a try. So the solution set for the equation, the square root of x plus 14 minus the square root of 2x plus 5 equals 1 is what? So we have to get rid of these square roots, ladies and gentlemen. We cannot solve for x when it's locked underneath a square root. So what I'm going to do is, first I'm actually going to rewrite this, make a little bit more room for myself. Okay. What I'm going to do first is I'm going to move this radical over here to the right-hand side of the equals. I don't want that negative. I like to work with positive numbers. So let's go ahead and do that right now. I'm going to add the square root of 2x plus 5 on both sides. Add the square root of 2x plus 5. Those cancel. we get the square root of x plus 14 equals 1 plus the square root of 2x plus 5. Now this, ladies and gentlemen, is where it's going to get a little bit messy. We are going to square both sides because now we have the square root of x plus 14 alone. We could square that, and we can, in fact, square this. Is it going to be messy? Of course it's going to be messy, but let's just take our time, go through it carefully. This is easy. This is just x plus 14. Once you square root, you just drop the square root symbol. Now this gets messy right here. So this is really saying 1 plus the square root of 2x plus 5, 1 plus the square root of 2x plus 5. Okay? So now what we are going to do here is simply distribute. So it's the 1 times the 1 times the square root of 2x plus 5 times the 1 times the, plus the 1 times the square root of 2x plus 5 times these two back here. So this is going to be x plus 14 is equal to 1 plus the square root of 2x plus 5 plus the square root of 2x plus 5 plus, now be careful here, the square root of 2x plus 5 times the square root of 2x plus 5 is just 2x plus 5. Okay? They're the same radicands, and we're just multiplying them twice with the square root symbol. Just drop the square root and keep what's underneath the radical sign. So now I'm going to combine like terms. It's getting a little bit cleaner, but we're not quite there yet. I could combine the 5 and the 1, the 2x is by itself, and I could actually combine these two things over here. Those are both the same thing. So I could just throw a 2 in front of one of them. So this is just x plus 14 is equal to 5 plus 1, which is 6, plus 2x, plus 2 times the square root of 2x plus 5. All right, a little bit cleaner. Not quite there yet. How about we do this? Let's go ahead and move all of this stuff that you see here. Let's move this stuff over to this side. Because again, the x is still stuck underneath the square root. We got to get rid of it eventually. So let's go ahead and move this stuff over. So just subtract the 6 and subtract the 2x. Subtract the 6 and subtract the 2x. So we get x minus 2x is negative x. 14 minus 6, that's a positive 8. That's equal to 2 square root of 2x plus 5. Now we're going to divide by that 2. Okay? Again, a little bit messy, but that's okay. So you have negative x plus 8 divided by 2 equals the square root of 2x plus 5. Now we're going to square both sides. Okay, this could get a little messy. We could do it, though. Once we square both sides, the top of this becomes negative x plus 8 squared. Leave it as is. Don't touch it. Divided by 2 squared is 4. That's equal to 2x plus 5. We still need to solve for x, though. So I'm going to move this to the left-hand side. I know, it's a little messy, right? We're going to move this to the left-hand side, okay? So we get, and I'm actually going to FOIL this in the process. So this is really negative x plus 8, negative x plus 8. That's going to be x squared minus 16x plus 64, all divided by 4. Okay, so this can be rewritten as 1/4 x squared minus 4x plus, let's see, that goes in 1 time with a 2, that's 16. That equals 2x plus 5. So what I just did is I just took this and rewrote it in a more simplified form down there, okay? So from here, I'm going to move that 2x and the 5 over. Now it seems more appropriate, right? Not before. Minus 2x minus 5. Okay? We get 1/4 x squared minus 6x plus 11, set it equal to the number 0. Oh boy. Now, this is where it gets a little tricky. We can use the quadratic formula, and honestly, I would so do that, but I'm just getting a little bit lazy. Go to Menu, Algebra, Polynomial Tools, find the roots or the complex roots. If you actually, you know what? No, we want to find real roots because everything's in real roots. So Menu, Algebra, Polynomial Tools, find the real roots. I'm typing in 1/4 x squared minus 6x plus 11, comma x. I'm getting 2 and 22. So x is equal to 2, and x is equal to the number 22. And those, ladies and gentlemen, are, in fact, your answers. And the answer, let's see. Well, if it's 2 and 22, we just have to double check and see if it works. So if we take 2 and we plug it into the original equation. All right, again, I'm lazy. I'm just going to go to my calculator and do it. So I'm going to take 2 and I'm going to store it into x. So control var x. Go ahead and type in exactly what you see. So the square root of x plus 14 minus the square root of 2x plus 5. Does that equal 1? True. Nice. So we know that 2 is an answer. Let's try 22. Enter that. Copy and paste. 22 is false, so therefore that is an extraneous root that's rejected. Now your final answer is x is equal to 2. So that, ladies and gentlemen, is your answer. If you want to know how to factor this, by the way, there are 2 options that you could do. Either you can multiply this whole thing by a 4, because here's the deal. That 1/4, you can't factor using 1/4. You just can't, okay? That has to be a 1. So if you actually multiply this by 4, that will give you, if you distribute that 4, that gives you x squared minus 24x plus 44. Set that equal to 0. And as you can see here, the factors are x minus 22 and x minus 2. That's how I got those roots in the calculator. I just didn't show that to you. But that's the way to get those roots algebraically. You just have to multiply that by that 4 because this has to be the number 1. You can't factor otherwise. I mean, you can by using the quadratic formula, but who wants to do that, right? So it's so annoying. But anyway, your answer is choice 2 because the other root was in fact, oh, that's tiny. The other root was in fact extraneous. There we go. Moving on to number 5. As x increases from 0 to pi over 2, the graph of the equation y equals 2 tan of x will what? So it's saying here, as x increases from 0 to pi over 2, what will this graph do on the domain from 0 to pi over 2? Okay, so if you don't remember the tangent graph, that's okay. You could just go to your graphing calculator and type in 2 tan of x. 2 tan of x. Then go to your menu page. Go to menu. Go to window zoom, window settings. And I'm going to go from 0 to 2 pi. No, sorry, not 2 pi. Pi over 2. Pi over 2. All right, ignore the x scale, but I already know what it's going to be. I'm just going to make this pi over 4. Just ignore what I just did. And the minimum y value, I'm just going to make it negative 10 for the heck of it and make this 10. And make the auto 5, I guess. Okay, so this, ladies and gentlemen, is the graph of 2 tan of x from the interval from 0 to pi over 2. So bear with me while I take a picture of this, and I'm going to put it on my software over here. Sorry if that, I keep forgetting to turn off the volume. I'm sorry. That probably just hurt all people with earpieces in them. Rest in peace. So there we go. Okay, so we have this, right? It's asking you what is the limit as x increases from 0 to pi over 2. Well, as x goes from 0 to pi over 2, what is happening up here? Well, it's increasing without a limit. Your answer is choice 3, okay? So, how do we know that? Well, tangent, we know that tangent is undefined at 90 degrees, okay? 90 degrees is, in fact, pi over 2, okay? So since we know that it is undefined at pi over 2, for example, if I were to just type in a relation, so if I go to graph entry edit and I type in relation and I type in x is equal to pi over 2, look at what's going to happen. As you can see, if I slowly shift over here, it is not going to, actually, let me change the color here. It's not going to even touch this or even pass this. This is actually a vertical asymptote. So no matter how far you go up, look at this. I'm already at 131 for the y values. It doesn't ever touch it. So we know for a fact that it will increase without limit. It will go on forever. Now, I'm just super excited to tell you this because you guys are in Algebra 2. You will see this stuff in calculus denoted as the limit as x approaches pi over 2 of 2 tan of x will equal infinity. And you will see what the heck this means in calculus if you stick around for a couple more years, because I will be doing calculus eventually. So make sure you hit that subscribe button, right? So your answer is choice 3. Anyway, moving on to number 6. All right, so which equation represents a parabola with the focus of 0, -1 and the directrix of y equals 1? So when you hear the words focus or directrix, I want you to think of one common formula that you need to know. And that is y equals 1 over 4p times x minus h squared plus k. That is important information. When you hear that word, you want to think of this form of a quadratic, okay? So, what do we know about the focus and the directrix? Because we need to find the equation that represents this information. Well, we know this. The focus is always in the form of h, k plus p. And we know that the directrix is always in the form of y is equal to k minus p. Now, what's nice about this is we are given information. We're given the focus at 0, -1, and the directrix of y equals 1. So, if we have a focus at the point 0, -1, well, we could conclude a couple things, and I like to create a sidebar right here. It's for my information. Our goal really is to find the values of h, k, and p. That's what we're looking for, folks. So when we find the value of h, take 0, -1, right? 0, -1, and find what these values are. Well, 0 automatically is the value of h. So h is 0. We're done with that, right? Now, we do know that k plus p is the value of -1. So k plus p is the value of -1. Okay. And the directrix is y equals 1. Well, that's your directrix. Well, if y equals 1, but y also equals k minus p, we could conclude from this information that it's not y anymore, it's k minus p equals 1. And this is our goal, really. Our goal is to set up a system of equations to solve this, because we know that, again, k plus p does equal -1. So what we're doing is we just set up a system of equations. We are now going to solve for the values of k and p. Okay, let's go ahead and do that right now. So, when solving for k and p, the p's cancel when we add them up together. This gives us 2k is equal to 0. Okay, divide by 2 on both sides. It really doesn't matter, but k is equal to 0. So go back up here. We know that k is 0 as well. Well, now let's find the value of p. Take k equals 0 and just plug it in to one of these equations. Let's plug it into the one up here. Well, if k is 0, well, that's just 0 plus p equals -1. P must equal -1, right? So, there we go, -1. So now what we need to do is take all this information and plug it in into our formula, right? So when we plug this into our formula, we are given the following. This really becomes y is equal to 1 over 4p, which is -1, times x minus 0 squared plus 0. Well, this is just another way of saying y equals -1/4 x squared. Well, is that here somewhere? I'm not seeing anything so far. It doesn't look like that. So what we need to do is say, all right, they're not going to fool us. Let's go ahead and simplify each equation. Now, if you play it smart, I see 8s and 4s. Get rid of any answer with 8s because I don't see a 2 to offset it to get a 4. So that's out. Take a look at choice 2. X squared equals -4y. We'll just divide by that -4 on both sides. Hey, what do you know? That's the same thing as what we have over here. Sweet. So we just got our answer. Your answer for this question is going to be choice 2. Not too bad. Just understand focus and directrix and you're good to go. All right, cool. Moving on to number 7. Number 7 says, which diagram represents an angle alpha measuring 13 pi over 20 radians drawn in standard position and its reference angle of theta? Now, understand a couple things real quick. The reference angle theta must always be acute. So if you're given any theta that's obtuse, or it's acute and it touches the x-axis, that's another important point. So if you have a theta that's obtuse or it's not touching the x-axis, then it's not the right answer. So take a look at choice 1, for example. Theta is obtuse. Nope. Take a look at choice 2. Okay, that's acute, and it's touching the x-axis. So far, that's in the running. Theta, it's acute, but it's touching the y-axis, not the x-axis. So that's not true either. And theta is acute and touching the x-axis in choice 4. So we're good so far, right? So let's go ahead and convert 13 pi over 20 radians to degrees. So 13 pi over 20. To convert it into degrees, you multiply by 180 over pi. That gets rid of these pi's over here. So now all you need to do is go to your calculator, type in 13 over 20 times 180. We get 117. So we're talking about alpha is equal to 117 degrees. Well, where is 117 degrees? Well, it lies between 90 and 180. So it has to be somewhere in quadrant 2 is where we're looking. So looking at choices 2 and 4, alpha is going negative in the negative direction. Yeah, it does terminate in quadrant 2, but why is it going in the negative direction? We have 117 degrees that's positive, but it's saying which diagram represents an angle. It has to measure 13 pi over 20 radians. Yeah, well, your answer is going to be choice 4. This, on the other hand, is the negative of. Now it's not negative 13 pi over 20. You just simply take 360 minus the 117, get that answer, and negate it and convert it into radians, and that's what gives you this answer. But they're not asking you for that. They're specifically asking you for angle alpha that's positive 117 degrees and the reference angle that's touching the x-axis. So for this question, your answer is going to be choice 4. Moving on to number 8, what are the zeros of P of m equals m squared minus 4, m squared plus 1? So, basically it says find the zeros. You're finding the roots of the quadratic. Actually, I'm sorry, in this case, it's not a quadratic, it's a quartic function. So all you're doing is you're setting everything equal to 0. Fine, we know how to do this. So we have m squared minus 4, m squared plus 1, set that all equal to 0. T-bar. Well, I mean, could you factor? Yeah, you could factor. But honestly, you could just do m squared minus 4 equals 0, m squared plus 1 equals 0. Add the 4 on both sides. You get m squared equals 4. Take the square root of both sides, and you get m is equal to plus or minus 2. Okay. Over here, subtract the 1. We get m squared is equal to negative 1. Take the square root of both sides. Uh-oh, we have m is equal to plus or minus I. So that's an imaginary unit. But here's the deal, people. Do you just reject the i's and say 2 and negative 2 only? They're both of them. So your roots are actually choice 4. 2, negative 2i, and negative I. Now you might be saying to yourself, yo, Trev, what are you talking about? Those are imaginary numbers. There's no way they could be zeros. Well, by definition, a 0 is just simply setting the quadratic, or whatever function you're working with, in this case a quartic, equal to 0 and solve. We did that already. We set it equal to 0. We solved it. We got these numbers. And I is technically a number. It's an imaginary number. And those are your zeros. If they were asking you, however, for the real roots of the quartic function, it would only be positive 2 and negative 2. But they want everything. So your answer is going to be choice 4. Don't be fooled by that. Know what they're asking. Number 9, the value of a new car depreciates over time. Greg purchased a new car in June 2011. The value V of his car after t years can be modeled by the equation log of base 0.8 of V over 17,000 equals t. What is the average decreasing rate of change per year of the value of the car from June 2012 to June 2014 to the nearest $10 per year? So here's the deal, what you need to do. From June 2012 to June 2014, it looks like to me that only 2 years went by from June 2012 to June 2014, right? So here's what you want to do. This is a log function, all right? And you actually want to solve for the average decreasing rate of change. Well, that is code that you should know. That's another word for slope. So we're actually just doing the change in y over the change in x. But the problem is, folks, is we actually need to solve for the value of t. We need to find out how much time goes by, okay? So here's what we're going to do. I am going to loggy loop this, or log loop. So remember that this is in the log form. The log form, let me write this down here. The log form is always written as log bn equals e. And it could be transformed into this type of an equation, be equals n, which is just the exponential form. This is the logarithmic form. And remember that logs are exponents. We could easily write this in an exponential form just by doing the log loop. B raised to the exponent is equal to the number. Okay, so what we have here is when I rewrite this in the Ben form, we have 0.8 raised to the t is equal to v over 17,000. Okay, great. Now, solving for v, because v is the value of the car, we need to find out to the nearest $10 per year. So we're looking for v divided by t, dollars over years. That's what we're going for, ladies and gentlemen. So right now, I'm going to solve for v. We're going to cross multiply. Very simple. So v is equal to 17,000 times 0.8 raised to the t power. Okay, so now we have to find the slope. The slope is the change in y over the change in x. But you know that this is really asking for the change in dollars over the change in time. Okay? Because that's what it's asking for. To the nearest $10 per year. That per means divide by the amount of years. So let's go ahead and do that. It's saying from June 2012 to 2014. Well, how many years is that for in terms of the context of the problem? Well, this is where it gets tricky here. Look at what it's saying here. Greg purchased the car in June 2011. They want to know from June 2012 to 2014. Well, technically speaking, how many years went by past since June 2011? Well, for June of 2012, 1 year passed by, and for June 2014, 3 years passed by based off of June 2011. So we're actually looking for when the time is 1 and the time is 3. So this is what I'm getting at here. Your slope is going to be the change in y over the change in x. You're looking for the y values when x equals 1 and 3. So this is really going to be 17,000 times 0.8 raised to the third power minus 17,000 times 0.8 raised to the first power divided by 3 minus 1. And that, ladies and gentlemen, is actually your slope to answer this question. This is technically speaking the change in the dollar amount because I just plugged in the values of time, which is 3 and 1, divided by the time, 3 minus 1. So I'm going to go ahead and type this into my calculator and solve it. So we get 17,000 times 0.8 raised to the third power minus 17,000 times 0.8 raised to the first power. And this is all divided by 3 minus 1. That has to go in parentheses because I know it's going to screw it up. Okay. Negative 2,448. Negative 2,448. Your answer is choice 3. That is the closest to it. Now here's why it's not negative. What is the average decreasing rate? So they're telling you what is a decreasing rate. They express them all as a positive answer because they know it's going down. So that's why. See how they're trying to fool you? They know it's decreasing, so they made them positive answers. But again, it says what is the average decreasing rate, so we know it's technically negative. And the rounding is so bad here. I mean, the slope is negative 2,448. It's off by 2. Honestly, I don't understand the point of them doing that stuff. I don't know why they just can't give you the exact amount because it is a nice amount. It's negative 2,448. But they just decided to round it to 2,450. But we know that that's the answer. Your answer is choice 3. Moving on to number 10. Iridium. Oh boy, it's been a long time since I've taken chemistry. Iridium-192 is an isotope of iridium and has a half-life of 73.83 days. If a laboratory experiment begins with 100 grams of iridium-192, the number of grams A of iridium-192 present after T days would be that. A equals 100 times 1/2 raised to the T divided by 7383. Which equation approximates the amount of iridium-192 present after T days? So basically what you're doing is this. All they're doing is they are rewriting this, where this information, that 1/2 times T over 7383, is simplified as a decimal, okay? Honestly, I do not know where these answers, I don't know where they're getting these answers from. Oh, I'll tell you where they're getting these answers from. They want to confuse you and say, okay, yeah, 1/2 times 7383 is 1 over 147.66. That breaks so many laws of mathematics. It's so not funny because it breaks so many rules. And then where are they getting this from? 7383, just what, you move it into the numerator and divide by 2? No, that doesn't make any sense. You're looking at choices 3 and 4. Something is with these decimal places that has to match with this. Well, how do we do it? Well, we just take 1/2 and raise it to the 1 divided, oops, that's an ugly 1. We just take 1/2 and raise it to the 1 divided by 7383, okay? And that will give us the approximation after T days. And that is approximately equal to 0.990656. And that, ladies and gentlemen, is going to be choice 3. So all they did is on the first, is when T equals 1, they plugged in 1, and this is the number that we're looking at. And any value of T after that, so 1, 2, 3, 4, 5, no matter what number you plug in for T, it's actually going to match the original equation. So this is just a simplification of the original. Okay, so that's really all they're testing you on. Your answer is going to be choice 3. Moving on to number 11. The distribution of the diameters of ball bearings made under a given manufacturing process is normally distributed with a mean of 4 centimeters and a standard deviation of 0.2 centimeters. What proportion of the ball bearings will have a diameter less than 3.7 centimeters? So this is obviously in your calculator, normal CDF. Okay, so normal CDF, we need a lower bound. We need an upper bound. We need the mean or the average. And we need the standard deviation. Okay, so we're gonna basically list all the information that we know. Well, the mean they tell us is 4 centimeters. The standard deviation is 0.2, and it's saying what proportion of the ball bearings will have a diameter less than 3.7. So that means that the diameter could be 0, or the diameter could be less than 3.7. So the upper bound is 3.7, the lower bound is 0, just to include those very, very, very small ball bearings. Go to your calculator. Go to Menu, Statistics, Distributions, Normal CDF. We're going to type in the lower bound of 0, upper bound of 3.7. The average is 4, and the standard deviation is 0.2. Click OK, and your answer is going to be 0.06681. So this is going to be 0.06681. Right? Yes. And your answer for this one's going to be choice 1. Not too bad of a question. Just really, it's all calculator stuff. Last question of the video, number 12. A polynomial equation of degree 3, p of x, is used to model the volume of a rectangular box. The graph of p of x has x-intercepts of -2, 10, and 14. Which statements regarding p of x could be true? I always hated those types of questions. Could be true. You know, could be meaning sometimes true. Okay. So if it's degree 3 and it has the x-intercepts of -2, 10, and 14, here's what's nice about this. If the x-intercepts are -2, 10, and 14, and it's a degree 3 polynomial, we know for sure that p of x has to be x plus 2, x minus 10, x minus 14. We know this. We know it has to be that. There's there are 3 independent roots. And I just took its opposite values to put them in factored form. So we know that this is the equation of p of x. So let's go to match some things. The equation of p of x is x minus 2, x plus 10, x plus 14. No. They were trying to trick you. They want to see how many people would get tripped up at the fact that you don't change the sign when you plug into the factors. Not true. So that's not okay. B says the equation of p of x equals negative x plus 2, x minus 10, x minus 14. Well, x minus 10 and x minus 14 are good. Well, I see an x plus 2, but I see a negative Well, is that true necessarily? Well, and here's what's pretty nasty about this part, right? Here's what's nasty. It doesn't say anywhere in the instructions that the leading coefficient is positive. It doesn't say anywhere about that. So technically, so forget about the negative sign for a second. This is our equation that we got. But what I did not mention to you is that a negative sign could also satisfy those same conditions. The negative sign doesn't change a thing. Doesn't change a thing. The only thing it really does change is the end behavior of the function. Well, that could be true. Yeah, it absolutely could be true. Because it still has those same roots. It's just the end behavior is different on the function. So it doesn't make a difference. Take a look at C. The maximum volume. Maximum volume occurs when x equals 10. So when it says that the maximum volume occurs when x equals 10, let's just really go ahead and graph this. So I'm going to graph this as a positive leading coefficient first, just because I know that volume is always positive. I've never seen a box that had negative volume. I need to zoom fit this. Menu, zoom, fit. Now, when x is equal to the number 10, well, how does that make any sense? If the maximum volume is x equals 10, that's a root, right? That's a root. That makes absolutely no sense. We know specifically that 10 is a root, and that means that the y value must be 0. It means that there's no box anymore, or yeah, there's no box. You can't fit anything inside. So that can't be true. And as you can see clearly on the graph, right? This is 10. I mean the maximum is somewhere up here, right? Or actually it could be it could be any of that up there. I mean, it would be nice if they give us a specified domain, but this is a relative max in here, and somewhere up there is some infinite amount. The maximum volume of the box is approximately 56. Let's see. The maximum volume of the box is approximately 56. So let's find the maximum y value on this graph. Let me zoom out here just a little bit. Zoom, window zoom, zoom out. Let me just make sure. So, okay. So this definitely does go off in the infinite direction forever. But, I mean, you can't have an infinite box. So what they're actually asking you for is a relative maximum. A relative maximum is just on a closed specified domain. So we're actually looking right over in this vicinity over here. So let me zoom out just a little bit more. Zoom out. I know it's somewhere over here. So menu, analyze graph, maximum. Click before and click after. The volume of the box is 388. Well, that's not necessarily true. Let's go ahead and find out. Let's see here. So let's try, I don't know, menu. Actually, you know what's nasty is it could be 388, but it also could be that other satisfied condition. Let's just go ahead and put a negative out here. Let's see what happens. If I put a negative out here, does it change the situation? If it changes the situation, then I'd be like, okay, well, clearly it's 56. So let's try this maximum over here. So menu, analyze graph, maximum. Click before and after. Okay. So that's a nasty question, people. That's a nasty question. Forget that point. The one before was like 388, but that was a maximum when it was a positive leading coefficient. This is a negative leading coefficient. The maximum is 56.3. So that could be true as well. So you have to be so careful with that plus minus out front. So your answer is actually choice 4, B and D. Very, very tricky question. Had to know some things about graphs. All right, that is the conclusion of this video. I hope that it helped you. Make sure to hit that subscribe button down below. Consider becoming a patron on my Patreon page. I would greatly appreciate it. I do this for no charge, and I would like to keep this channel going for many, many years to come. And make sure that you visit my website at www.nysmathregentsprep.com for more math content in Algebra 2. You see a lot of things on my website for Algebra 2 and your future mathematical subjects, and I hope to see you soon.